Welcome to The Explainer. Sometimes the biggest mysteries are hiding in plain sight. Today, we're going to tackle a few of them, and they all have to do with something you see every single day: water.
So, let's kick things off with this really smart observation from a kid named Throv. He's looking at solid ice floating in liquid lemonade, and he's thinking, hey, one is hard, one is flowing. They've got to be different things. And you know what? That makes total sense, right?
So, that's the big question, isn't it? Is that block of ice truly a different substance from the water it melts into? Let's put on our detective hats and see if we can solve a couple of everyday puzzles to figure it out.
All right, let's open our first case file. We're going to investigate the classic, unsolved case of the disappearing puddle. We've all seen this a million times. After a good rain, the world is just covered in these little pools of water, sparkling on every surface. But then, life happens. You go about your day, and when you come back to look, poof, they've vanished, like they were never even there.
Okay, so the obvious thought is, well, it just soaked into the ground. And yeah, sure, some of it does. But what about the puddle on, say, a metal slide? Or when you mop the kitchen floor? That water can't soak in. So seriously, where did it go?
Well, here's the secret. The water didn't just disappear. It changed. It went through this amazing process called evaporation. That liquid water turned into a gas. We call it water vapor, and just floated away into the air. It's still there. You just can't see it.
And this isn't just about puddles. I mean, think about it. It's the exact same thing that's happening when your wet clothes dry on the line or that mopped floor becomes dry to the touch. It's even how your body cools itself down with sweat. Evaporation is literally happening all around us, all the time.
Okay, you ready for mystery number 2? This one's a real head-scratcher. It's where water seems to just appear out of thin air. So imagine this scene. It's a warm day, and you pour a super cold glass of ice water. The outside of the glass is completely dry. You're sure of it.
And yet, you walk away for a few minutes, come back, and look at that! The outside of the glass is now covered in these little beads of water. It looks like the glass is sweating. So, what's going on here?
So we've got a couple of possibilities, right? Theory 1, maybe the glass has these teeny tiny holes and the water is actually leaking out. Or Theory 2, the water isn't from the inside at all. It's somehow forming from the air around the glass. What do you think? Okay, get ready for the smoking gun. This is the clue that blows the case wide open. If you were to put that glass on a super sensitive scale, you'd notice something incredible. Its weight actually goes up. Now hold on. If water was leaking out, the total weight would have to stay the same. The fact that it gets heavier, that's proof. The water has to be coming from somewhere else.
And that somewhere else is the air itself. Remember that invisible water vapor from our disappearing puddle? Well, this process, condensation, is its exact opposite. When that humid air touches the cold glass, it cools down so fast that the vapor turns right back into liquid water droplets. Case closed.
So, let's put these clues together. Water isn't magically appearing or disappearing. No, it's just changing its costume. We've seen it go from a liquid to a gas, that's evaporation, and from a gas right back to a liquid, that's condensation. They aren't different things at all. They're just different faces of the same exact stuff.
And this takes us all the way back to Throv and his lemonade. He was right that ice and water feel different, but they aren't different substances. They're just the three states or faces of water. You've got ice, the solid, with its own fixed shape. Then you have liquid water, which just takes the shape of whatever you pour it into. And finally, there's water vapor, the gas, which spreads out to fill up any space it's in.
And it all connects in this really elegant cycle. If you add heat, solid ice melts into liquid. Add more heat, and that liquid evaporates into a gas. Then just do the reverse. Take away heat, and the gas condenses back into a liquid. Take away more heat, and that liquid freezes right back into solid ice. It's a perfect loop. Okay, so we've cracked the case of the puddle and the sweating glass. Pretty cool, right? But why does any of this really matter? Well, it's because these exact same simple ideas are what power a gigantic machine that makes our entire planet work.
I mean, think about the sun. It's like a massive space heater just blasting our oceans with energy.
That causes unbelievable amounts of evaporation. All that water vapor rises up, and high in the atmosphere where it's cold, it does the exact same thing it did on our cold glass. It condenses into trillions of tiny droplets, forming clouds. And when those droplets clump together and get too heavy, boom, we get rain or snow. That's the global water cycle. It's our little experiments, but on an epic, planetary scale.
When you really understand this incredible cycle, how water travels, how it changes, how it nourishes everything, it just makes you see it differently. And this quote here, it really hits home. It reminds us that all the water we use is part of this ancient global system, a system we have a real responsibility to take care of.
So, I'll just leave you with that to chew on. Now that you know that every single drop of water, from a raindrop to the water in your glass, is on this amazing, continuous journey, does that change how you think about it? What does that responsibility mean for us, right here, right now? Thanks for joining me on The Explainer.